So let us start these questions. This is an elementary question where we just need to expand this using the binomial theorem. So either you can start writing the theorem directly, or first of all you can indicate the formula that x plus y raised to power n is equal to sigma r goes from 0 to n ncr x raised to power n minus r into y raised to power r. This was the formula. And how do we write it in expanded form? Now this is sigma. Sigma means summation, and r goes from 0 to n. So r will take these values 0, 1, 2, 3, 4 and up to n, right? So how do we write this in expanded form? So I'll start with r equal to 0. The first term will be nc0 x raised to power n minus 0 y raised to power 0. So this is the first term. nc1 x raised to power n minus 1 y, nc2 x raised to power n minus 2 y squared, nc3 y raised to power 3 x raised to power n minus 3. This is how we have learned this formula. And then ncn y raised to power n x raised to power 0. So this is the formula. Now it is your choice whether you want to write this first or this formula first, or you want to expand it directly. Now let me expand it. So this will be equal to, what is n in this case? When I write the formula for x plus y raised to power n, so what is n in this case? N is equal to 4. nc0, so 4c0, I'll start it with 4c0, and then 3 by x raised to power 0 and x squared raised to power 4. This is how we write the formula. 4c1 3 by x raised to power 1 and x squared raised to power 3 plus 4c2 3 by x raised to power 2 x squared raised to power 2. 4c3 3 by x raised to power 3 x square raised to power 1. 4c4, if somebody is confused why I'm writing 3 by x raised to power something first and then writing about x square, okay, then you need to go to my theory lecture first, the introduction lecture. If you listen to that introduction lecture, these questions are nothing for you. So 4c4 3 by x will take the fourth power and x square will be raised to 0th power, so I don't have to write it. Now what about these values? 4c0 is 1, right? And this raised to 0th power is 1, so x raised to power 8 plus 4c1 is 4, x square raised to third power is x raised to power 6. So let me write it as x raised to power 6, and then this will be 3 upon x plus 4c2 is what? 4 into 3 by 2 into 1, so it is 6, okay? Or let me write it 4 into 3 by 2 into 1. In the next step we will write it in simplified form. X square squared x raised to power 4, 3 by x squared, so it will be 9 by x square plus, and then there is 4c3 which is nothing but 4c1 which is 4. X squared raised to power 1 is x square, 3 by x raised to third power, so it will be 27 here and x cubed here. Okay, and what will be the next term? This is the next term. 4c4 is 1, 3 raised to power 4 is 81 by x raised to power 4. Now let us write it in a little more simplified form. So it is x raised to power 8 plus 4 into 3 12, and this x raised to power 6, so it will become x raised to power 5, 12 x raised to power 5. Similarly this is 6, this is 9, so 6 into 9 is 54, and this is x raised to power 4, this is x square, so it will leave x square here. And 27 into 4 is 108, so 108, and this is x square by x cube, so 108 by x plus 81 divided by x raised to power 4. This is your expansion. I hope you face no difficulty in expanding elementary questions like this. So let us do some more questions. Let us look at the next one. 98 raised to power 5. So we need to expand this 98 raised to power 5 using the binomial theorem, right? So let me write it like this: 100 minus 2 raised to power 5. Now the expansion, we will start with 5c0, we will go up to 5c5, right? This is what we do. Whatever we write here at this place, we raise this term to that power. So I am considering this term to be minus 2. Okay, so I'll raise minus 2 to the 0th power and the rest of the power. So now the sum of exponents has to be 5. So if 0 comes here, here it will be 5. And what is the term here? 100. How will we write the next term? 5c1 minus 2 raised to power 1, 100 raised to power 4. 5c2 minus 2 raised to power 2, 100 raised to power 3. 5c3 minus 2 raised to power 3, 100 raised to power 2. 5c4 minus 2 raised to power 4, 100 raised to power 1. And then finally 5c5 minus 2 raised to power 5 and 100 raised to power 0. So let us write 5c0 is 1, 100 raised to power 5 is the first term, plus 5c1 is 5 and this will be minus 2, right? So minus 2 into 5 is minus 10. Minus 10 into 100 raised to power 4 is minus, let me write minus 10 separately and 100 raised to power 4 separately. We will deal with it a little later. Okay, so this is 5c2. 5c2 we know 5c2 is 10, right? Because it is 5 into 4 by 2 into 1. So it will be 10 and this will give you 4 here. So let me write it as 40 into 100 raised to power 3. 5c3 is nothing but 5c2, which is 10. So 10 into minus 8 will become minus 80 into 100 squared. This is just a calculation. Other than that, this is simple formula that we have learned, right? 5c4 is 5c1, which is 5, and minus 2 raised to power 4. So 2 raised to power 4. 16 into this 5 will become 80. 80 into 100. Plus, this is 1, this is 1, minus 2 raised to power 5 is minus 32. This is a simple addition problem, right? 100 raised to power 5 will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. Let me write it in a bigger font. So 100 raised to power 5, I am writing it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 100 raised to power 4, right? So 100 raised to power 4 will have 8 zeros in the end. And when multiplied with 10, it will become 9 zeros. So, and you have to subtract it from this because this is minus sign. So I'll write it here. Minus 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and this is 100 raised to power 3. So it will end with 6 0, 1 followed with 6 zeros, and this will make it 7 zeros. 4 followed with 7 zeros, and you have to add this. So 4 followed with 7 zeros. 1, 2, 3, 4, 5, 6, 7. Now this is minus 80 and 100 squared. So it is 4 zeros, 5 zeros, minus 8 with 5 zeros in the end. So minus 8, 1, 2, 3, 4, 5. And this is 80 into 100, so 8000. plus 8,000, right? And this is minus 32. So let us check. If I deal with these two terms, what will it be equal to? Or what should I do? I should add these separately and then subtract these. So let us do that. This is a calculation, right? It will take me a lot of time. I expect you to do it yourself, but for this question, let me do it. Or let me use the calculator. So I expect you to do this addition problem yourself, but rather than wasting your time in this video, I'll use a calculator here, but you are not supposed to use the calculator. So this is what I've done. I've used a calculator and done this addition problem using the calculator. Okay, you are not supposed to use the calculator, but this is your answer: 903,920,7968. 903,920,7968. Right, this was your answer. And what was the calculation? I have done this calculation here. Okay, so all right, so this was the expansion. Rather than the expansion, this is a little more trickier because you might make a mistake here while doing the calculation, so you need to take care while doing the calculation part. Now which one is larger, this one or this one? So we will see by expanding it. Let us expand 1.01 raised to, how many zeros are there? 1 2 3 4 5 6 zeros. So 1 2 3 4 5 6. Now if I expand it, the first term will be 1 2 3 4 5 6 C0. And what is this term? I am writing it like this: 1 plus 0.01 this is a separate term that I am writing, raised to 1000000. This is how you need to think. 1 plus x, okay, where this is x. So this is how we will do it. Now the first term is going to be 1, which is this, or let us raise 0.01 to 0th power. This is the first term. So what will be the second term? 1 2 3 4 5 6 c1, and then 0.01 raised to power 1. This is the second term, right? You remember this: 1 plus x raised to power n is nothing but nc0 plus nc1x plus nc2x squared plus and so on, ncnx raised to power n. This is the formula that you need to keep in your mind. So I have written two terms. Let me write the third term: 1 2 3 4 5 6 c2 0.01 raised to second power. Now let us think about these three terms only. So this is 1, right? And this is 0th power. So this first term is going to be 1. What about this second term? This second term, nc1 is n, right? What is nc1? It is n. So this is 1 0 0 0 0 0 0 into 0.01. So it is 1 by 100 only, right? Then plus. Do I need to think about the third term? Let us check. 10,000. So if I cancel these two zeros, this is 10,000 plus 1 already. Now I will be adding some more terms here, right, which are positive terms. So this plus something positive is definitely greater than 10,000. So I can say 1.01 raised to power 1 2 3 4 5 6 is definitely greater than 10,000. Okay, how? I expanded this and considered only first two terms, and while expanding first two terms only, I know that this term is greater than this because this is 10,001. Using binomial theorem, prove that 6 raised to power n minus 5 raised to power n always leaves remainder 1 when divided by 5. So we need to use binomial theorem in this. Otherwise, we have done such questions in principles of mathematical induction, and also in class 10th we have done these questions in number theory. So let us understand it from the binomial theorem perspective. This is 6 raised to power n, this is 5n, and we are talking about 25. So what I'll do is I'll write 6 as 1 plus 5 raised to power n, right, and expand it. Then I'll talk about this expression. First of all, let us see what this is. So this is nc0 plus nc1 5 plus nc2 5 squared plus nc3 5 raised to power 3 plus and so on ncn 5 raised to power n. You should be comfortable with these formulas, otherwise you'll keep thinking how I am writing it here. First of all, you should be comfortable with the formulas we did in theory lectures, right? So it is better that you memorize these. Otherwise, even if you listen to the theory lectures completely, you don't even have to memorize it. You know how to distribute this power n among this and this. Whatever power 1 will take, it will give you 1. So 5 will be raised to different powers. In the first term, 5 raised to power 0, 5 raised to power 1, 5 raised to power 2, 5 raised to power 3, 5 raised to power 4, and we can go up to 5 raised to power n, which is the highest that it can take. Alright, so let us think about this. This is 1. This is nc1 is n, so I can write it as 5n plus this is nc2 into 5 squared. So if you see the rest of the terms, 5 squared can be taken as common from the rest of the terms. So if I take it common, I'll have nc2 here, right? I've taken this outside, and from this I'll have nc3 into 5, then nc4 into 5 squared plus and so on, and then I'll have ncn 5 raised to power n minus 2. So this will be the expansion because I've taken 5 squared outside, and this is the expansion for 6 raised to power n only. But I need to talk about 6 raised to power n minus 5n. So let us think about it. If I bring this 5n on the left hand side, it will be something like this: 6 raised to power n minus 5n, and it is equal to, this is, let us say, equal to m. Okay, so this is 1 plus 5 squared 25, and this is m. So this expression 6 raised to power n minus 5n is equal to 25m plus 1, right? M is an integer. Why? Because if you see, these are all integers. NCR is an integer. It is number of ways of choosing R things out of n different things. So this is going to be integral. It can, and it will be positive integer. Okay, and this is 25 already, we know, and this is 1. So what is this pattern? 25m plus 1. So this is something that we studied in class 10th, that dividend is equal to divisor into quotient plus remainder, right? So if I divide something with 25, divisor if it is 25, then the quotient I am getting is m and remainder is 1. This is the meaning. This is the dividend. I am dividing it with 25. This is the quotient and this is the remainder. So 6 raised to power n minus 5n, if divided with 25, will give me remainder 1. Or the other way to think about it can be, if we look only at the right hand side, that is this term, if we look only at this term, what is this? 25m plus 1. So it has got two terms. This term is completely divisible by 25. So the remainder that I am going to get is 1. So if I divide this with 25, I will get remainder 1. And this is what we have proved using the binomial expansion. Expand each of the expressions in exercise 1 to 5. Okay, the first one is 1 minus 2x raised to power 5. Now these questions are very simple. I can expand it in 5 seconds, but the only part is the calculation part, which you need to be careful of. So the expansion for this will be, see the power is 5, so the coefficients I'll get is, I'll start with 5c0 and go up to 5c5, because I cannot have 5c6, right? This is where, this is up to where I can go. 5c6 is not a valid term, so I'll start with 5c0 and go up to 5c5, right? And then you know that in the first term here I'll write minus 2x raised to power 0. Second term I'll write it like this, minus 2x raised to power 1. Third term minus 2x raised to power 2, minus 2x raised to power 3, five c4 minus 2x raised to power 4, and then 5c5 minus 2x raised to power 5. Why am I taking minus 2x here and I am not taking the plus minus alternative signs? Because I don't want you to memorize a lot of formulae. What you can do is you can think in terms of the formula 1 plus x raised to power n. You just need to replace that x with minus x, right? That is what I am doing here. Okay, 5c0 is 1, something raised to 0 is 1, so this term is 1, plus 5c1 is 5, so I'll write 5, and let me do the calculation part also. This will be 5, this will be 5, this is minus 2, so minus 10, this will be minus 10x. Now see, this is 5c2, 5c2 is 10, and minus 2 squared, it is 4, so 40. This will be 40x squared. This is minus 8, this is 10. 5c3 and 5c2 are 10, right? 5c2 or 5c3, these are equal, and these are equal to 10. So 10 into minus 8 is minus 80, x raised to power 3. 2 raised to power 4, 16. This is 5. So plus 80, x raised to power 4. This is 1. This is minus 2 raised to 5th power, minus 32, x raised to power 5. See, 5c4 is nothing but 5c1. 5c1 and 5c4, these are equal to 5. What I am using here is that formula that we learned, NCR is equal to NC n minus R. I hope you are comfortable with these notations. So this is the expansion. This is the expansion for this. Okay, I hope there should be no confusion. Yes, what I am doing here is I am not writing this term here, 1 raised to power 5 or 1 raised to power 4, and I hope you understand why I am not writing it, because 1 raised to these powers will give you 1, and this is how we have learned that formula, 1 plus x raised to power n. Okay, so to be on the safer side, first you can write this formula itself, 1 plus x, or you can take 1 plus t here, because x is already given here in the question. So you can take 1 plus t or 1 plus a raised to power n, write that formula, then do this expansion, so that the examiner finds it easy to understand what you are doing here. Otherwise, this is a simple, basic thing that you are doing. Okay, so we have got this one now. So let us do the expansion. First, I would recommend that if you are writing a CBSE pattern exam, so first of all write this formula for the examiner. A plus b raised to power n is nothing but sigma r equal to 0 to n. A raised to, then you need to write the coefficient, that is NCR, a raised to power n minus r, b raised to power r, and this is the expansion that we will do. We will expand this, right? This is in summation form, we will expand this. So the expansion of this term will be, I'll start, see the power or the n in this formula is 5. So I'll start with 5c0, or let me write it in sigma form first so that you can memorize this form also. So let us write it in sigma form. So r goes from 0 to 5, right, because power is 5. and 5cr a raised to power 5 minus r and b raised to power r. So now what I'll do in the expansion is I'll start with r equal to 0 and then I'll put r equal to 1 and add that term, right? R equal to 1 and then add, then r equal to 2 and add that corresponding term, and so on. This will be the expansion. So let us check. I'll start with 5c0. I can go up to 5. So I'll start with 5c0 and go up to 5c5. So let us do that. 5c0 a raised to power 5 minus 0 b raised to power 0 plus 5c1 a raised to power 5 minus 1 b raised to power 1. 5c2 a raised to power 5 minus 2 b raised to power 2. You should be comfortable in every way. Otherwise, in the previous questions, what we have been doing is, when I wrote 5c1, I raised b with 1. 5c2, I raised b with second power, and then wrote rest of the power, gave rest of the powers to a. Anyways, let us write 5c3 a raised to power 5 minus 3 b raised to power 3. 5c4 a raised to power 5 minus 4 b raised to power 4. 5c5 a raised to power 5 minus 5 and b raised to power 5. This will be the expansion. Okay, now what are the values of a and b here? So this is what we need to solve. This is the formula that I've written by now. So let me solve it rather than writing the formula. 5c0 minus x by 2 raised to power 0, 2 by x raised to power 5. 5c1 minus x by 2 raised to power 1, 2 by x raised to power 4. 5c2 minus x by 2 raised to power 2, 2 by x raised to power 3. Then plus 5c3 minus x by 2 raised to power 3, 2 by x raised to power 2. 5c4 minus x by 2 raised to power 4, 2 by x raised to power 1. 5c5 minus x by 2 raised to power 5, 2 by x raised to power 0. Let us check. This is 1. This is 1. So the first term will be 2 raised to power 5, that is 32 divided by x raised to power 5. You need to take care of this plus minus sign also. So this will be minus because of this minus sign here. 2 raised to power 4 in the numerator, that way. Now this is what? This is 5, right? This is 2 raised to power 4 by 2. So 2 raised to power 3, that is 8 into 5, 40. And this is x raised to power 4. So I'll have x cubed in the denominator. Look at this term. This is 10. This is 8. 10 into 8 is 80 by 4. So 20. Or you can think about it like this. This is 2 raised to power 2 in the denominator. This is 2 raised to power 3. So it will be 2 left here. And 5c2 is 10. So 10 into 2 is 20. Plus 20. And what will be the power of x? This is x square in the numerator, x cube in the denominator. So I'll have x in the denominator. What about this term? This is 10. Okay. And what about this? This is 2 raised to power 2, 4. And this is 2 raised to power 3 in the denominator. So effectively I'll have 2 in the denominator and 10 in the numerator. So that will give me 5. Why minus sign? Because of this minus here. And this is odd power. So x cube in the numerator and x square in the denominator will give me x in the numerator. Think about this. This is 5. And this is 2 in the numerator and 16 in the denominator. So 8 in the denominator and 5 in the numerator will give me 5 by 8 and x cubed. Okay, and this is 1, this is 1, this is negative, so minus x raised to power 5 by 32. I hope you would have found this calculation easy. There was nothing challenging apart from the silly mistakes, the possibility of making silly mistakes. Otherwise, there is nothing challenging. This is the next expansion, which also looks very elementary or very simple. It is raised to 6th power. So I'll start with 6c0 minus 3 raised to power 0, 2x raised to power 6. Right? Because the sum of these exponents is going to be 6. So what I'll do is, how am I writing the terms? When I write, see, I will go from 6c0 up to 6c6, right? 6c0, 6c1, 6c2, like this, up to 6c6. So whenever I write 6c0, so I'll raise this, the second term of this binomial, to this power, and then remaining, that is, the sum of exponents has to be 6. If I written 0 here, I'll have to write 6 here. If I write 1 here, I'll have to write 5 here. This is the expansion, right? So when I write 6c1, I'll raise minus 3 with 1 and 2x with 5, that is 6 minus 1. 6c2 minus 3 raised to power 2, 2x raised to power 4. 6c3, let us say in that term, minus 3 raised to power 3, 2x raised to power 6 minus 3. Okay, this is how you can say it. Then 6c4 minus 3 raised to power 4, 2x raised to power 6 minus 4, that is 2. 6c5 minus 3 raised to power 5, 2x raised to power 1. 6c6 minus 3 raised to power 6, and we know 2x raised to power 0 is going to give me 1. Let us calculate. This is 1, this is 1, 2x raised to power 6. So 2 raised to power 6 is 64, x raised to power 6. This is 6, this is 3, minus 3, right? So minus 18, 6 into, this is 2 raised to power 5, 6 into 32 into minus 3. So what is this calculation? This is minus 18 into 32. So what is 18 into 32? It is 576. And this is minus 3, right? So minus 576 x raised to power 5. What is 6c2? 6c2 is 6 into 5 by 2 into 1, that is 15, right? So 15 into 2 raised to power 4, that is 16, into minus 3 raised to power 2, that is 9. Okay, 240 into 9, so 0, 6, 2160. This will be plus 2160, and then x raised to power 4. What is 6c3? 6 into 5 into 4 by 3 into 2 into 1, right? I know the calculations can be little daunting, otherwise there is nothing in this question. 6c3 I am writing, 6 into 5 into 4 by 3 into 2 into 1, so it is 20, and you need to multiply it with 2 raised to power 3, that is 8, right? And this is minus 3 raised to power 3, so 27. We will write a negative sign here. So minus this product. What is this? 8 into 7 is 56. 16 plus 5 is 216 is the result of these two, and then it multiplied with 20 will give you 432 into 432 and is 0. 4320 x raised to power 3 here, so x raised to power 3, and then these terms are left. Okay, let's do these also. In some of the questions I may leave the calculation part to you, because that is fair enough, right? Because we should not spend a lot of our precious time on these calculation, at least in these videos, right? When it comes to the examination, or for you to do the practice, you should do the practice for calculation. I may not be doing this now, because you will be requiring that in your examination, right? 6c4 is 6c2, so 6 into 5 by 2 into 1, that is 15, right? So this is 15 into 4, that is 60, and 3 raised to power 4, so 60, this will be plus 60 into 81, right? And it will be equal to 64860, 4860, and x is raised to second power. I hope I have not missed anything. This is 15, this is 4, so 15 into 4 is 60, this is 81, so I think I haven't missed anything. 6c5 is 6, 6 into 2 is 12, 12 into 3 raised to power 5, and we will have a negative sign here, so minus, this is 6 into 2, 12, into 3 raised to power 5 is 243, right? So it will give you 6, 3, 51, 1, 5, 29. I hope the calculation is correct. And then how many x? X will be raised to first power, so x here. This is 1, this is 1, so minus 3 raised to power 6 is 3 raised to power 6, which is 729. Okay, please verify the calculation at your end also. Okay, so let us do rest of the questions in next part.